Looking at the 3.8 guided notes. This is the union and intersection of sets. Alright, so we've already talked about sets a little bit. So we want to recall that a set is a collection of elements. Now, when we have more than one set, sometimes they may share an element. Sometimes they don't share an element at all. The union of two or more sets is the set that contains all the elements in both sets. And in general, if we have set A and a set B, to denote the union of those, we put a union symbol here. So let's do just like a quick practice example. If A equals the set of red, white, and blue, America, and B equals the set of blue and gold. We're talking about colors. Oh, that looks like Jadidi. Let's say gold. O L D. Go Falcons. All right. Then the union of A and B, A union B, is the set of red, white, blue, and gold. So basically, it's all the elements in A or B. There we go. So that's an example of A union B. This is how we denote it mathematically. This is how we say it mathematically. Where U, this U thing, no tail, there isn't a tail here, this stands for the word or. So all the elements in A or B, that'd be red, white, blue, and gold. So A union B, all the elements in A or B. Okay, the intersection of two or more sets is the set of elements that are common to the sets. An element is in the intersection if it belongs to both of the sets. Sometimes, when two or more sets don't have a common element, they are called disjoint. This is a pretty crazy math word here. Disjoint means they have absolutely nothing in common. So if, let's say the universal set is all of the students in Mr. Stevens' class. That's the universal set. One of the subsets are the girls. The other subset are boys. In this instance, A, the intersection of B. Notice how the intersection is an upside down U. This stands for intersection. And we'll jot that down here in a minute. But A intersection B, this would be disjoint. Because there's no person in Mr. Stevens' class that would be a part of A and B at the same time. That would never work. So let's go back to this one here. Let's go back to that other scenario where we had a set A where it was red, white, and blue, and a set B which was blue and gold. Let's find the intersection of that. So I'm going to write this word, intersection. Intersection, again, is denoted by this in. I call it an in for intersection, but just know it's an upside down U here. All right, so A intersection with B in this scenario would be what, McGank? Let's take a look at the notes real quick. Let's take a look. The intersection of two or more sets is the set of elements that are common to the sets. If an element is in the intersection of it, an element is in the intersection if it belongs to both of the sets. So what would be the intersection of A, red, white, and blue, and B, blue and gold? What's in the intersection there? Blue. Good. Blue. Because it's the only element that is common to both A and B in this scenario here. And really, to be honest with you, that is sort of the whole idea. Just want to know what a union is. So you list all of them that are in both of them, that are in both sets. The intersection is the ones that are common to both sets. So let's try this out in practice here. We have an example. Let A be, this is in set builder, so the set of x values such that x is one of the first 5 letters in the English alphabet. So I'm just going to jot that down up here as A, B, C, D. A, B, C, D, E would be the 5th. So this is roster notation. We could say roster notation. Roster. Just so we remember, this is roster notation for A. B is a vowel. Okay, so in roster notation, B would be, what is it? A, E, I, O, and U. And C is all the set of x values such that x is a letter in the word vegetable. So in roster notation, that would be V, E, G, E, T. Well, I guess the E's would only go once. So it would be V, E, G, T, A, B, L. Okay. Now, there are 3 sets. So I want to know the intersection of A intersection with B and the intersection with C. So what do they all have in common? What do you think, Miss Owens? Give me one element that is in all 3 sets. E? Good. Awesome. E and A. Do they share anything else? Yeah, it has to be in all 3. Is there any of them that are common to all 3? That's it, right? So that would be the intersection of A, B, and C. A intersection with B intersection with C. That is just E and A. Now the union, A, union B, union C. All right, McGank, what is it? What is the union of all these? A. E is definitely there, yeah. That would be for the intersection. Remember, the union is the one that says or. In other words, it's the elements that can be in A or B or C. Remember, with the union, all we did was list every single one just one time. Right? I didn't have to list blue twice, even though it showed up in A and B. I just listed it one time here. Right? So when we go here, A and E are definitely a part of it, but so is C and D and B, because that's everything from the first element. So let's go to the second element. What is unique about this that I didn't have in here? An I, O, and U, right? So I got to get my I, O, and U involved. I, O, U. I got to list those. And now I want to list for C any of the letters in the word vegetable that aren't in A and B. So V would be another one. G. T. I feel like I'm on Wheel of Fortune right now. And L. So that is the union of these three sets. You know what I could do? I think I might not do this. Oh, bad spot. Bad spot. Bad spot. Delete. I'm going to do it like this. Here. Here. And here. So here, this is set A. This is my set B. This is my set C. We can look at this as a Venn diagram. So the ones that are common to all are E and A. So I'm going to just go get those in here right here. E and A. The ones that are unique just to the set B, well, let's continue this one. A, B is in more than one. C, nope. C is alone over here. What about D? Yeah, and so is D. B is shared between A and C, so there's B. What else is in B? I, O, U are unique just to B. I, O, and U are unique to B. And here we have V, G, and T. And my last one is L. V, E, G, E, T, A, B, L, E. Yeah, vegetable, that's all taken care of. Okay, so here, the union is all of those letters. So all I did is I picked out all these letters here. The intersection is just the one that's in all three. So it's helpful to think about sets and unions and intersections using Venn diagrams.